Hello everyone and welcome back to the Bug Bounty course series. We're still talking about bug bounty basics, but today we're going to be talking about some of the really easy vulnerabilities you can find when you're a beginner. And this kind of leaves us to today's topic, which is access control issues. Access control issues are by far one of the easiest bugs to find when you're first starting out. And that's for a bunch of reasons, but they're not overly technical. They don't require deep technical knowledge. They often require a time investment. They don't necessarily require like a monetary investment. Like you don't have to buy a tool, pay for something. It can often be done with any standard laptop or even a phone. And they're very difficult to automate. We'll look at some ways of making them easier. They can't really be searched for en masse with automated tools, scaled up like some other vulnerabilities can. They're a lot more tricky that way. So I think they're a really great place to start. And in fact, if you tell me what bug should I start looking for, access control issues. 150% access control issues. Always access control issues. So first off, we got to thank today's sponsor, BugCrowd. BugCrowd are actually sponsoring this entire series. They're what really makes it possible. So if you want to support the channel, please go sign up for an account. They've literally this week launched a program with OpenAI. So that's the people who make ChatGPT. And they've launched a program that covers ChatGPT. It's literally brand new. So maybe if you're looking at where can I apply my skills, have a look at that program. It's literally just launched. They've not had a bug bounty program before. And a lot of people are finding bugs. So that could be a really good one to kind of get started with, especially if you've got interest in AI. BugCrowd is the best place to start hacking, with a wide range of public and private programs from APIs to desktop applications and everything in between. Not yet ready to jump into a public program yet? Fill out your platform CV and sign up for a waitlisted program. Tell BugCrowd a bit about your skills, previous certifications or experience, and they'll match you up with the right program using their industry-leading crowd match technology. Whatever your level, there is a place for you in the crowd. So, access control. The idea of access control is that it's about restricting access to specific resources. So you can imagine this being like a key. So you can have a single key, or you can get a key cut and cloned and give it to several people, or you can have like a combination. And eventually broken access control means we just don't need a key. Now there's a lot of different ways that access control can be broken depending on the type of access control. However, as we'll see when we start to look at the demonstration, what this actually looks like in practice is fairly kind of straightforward. So there's a lot of different types of access control, and the three you'll see most often is role-based. So role-based means that every single user is given some kind of role, and that dictates what resources they have access to. So if you think about like a YouTube channel, you can assign an editor role, you can assign a moderator role, you can assign a whatever else role, and that depends on what people can do. If someone has a moderator, they might be able to delete comments, but they can't add new videos or delete videos. So that's role-based access control. Then you have discretionary access control. So with discretionary, this is where you see like a share on something like a cloud, or where you say, hey, these specific people I would like to share this with. So in terms of what broken might look like there, that would be someone be able to access it even if they haven't been given permission using the link settings. While something like role-based access is being able to do an action you shouldn't be able to do. And the final one is attribute-based, probably the rarest you see in web applications. The idea of these is it's kind of halfway between the two, but not really. In attribute-based access control, you list a big list of permissions and you say this user or this role has these permissions. And then you kind of get the best of role-based and the best of discretionary, in the sense that it's really easy to manage these because you can see what permissions people have, but you can also specify for a single individual, oh yeah, they're not just a moderator, they also need to be able to add captions to videos, for example. So you can kind of add additional permissions. And with attribute-based, as you can kind of imagine, it gets complicated really quickly. So this is where the kind of security sits into this, which is that with all of these types of access control, it can be really hard to kind of answer that key question is, what should this user be allowed to do? And the only way you can test that is by seeing what your user can do and thinking with your brain and thinking, should they have permission to do that? So what are the signs of access control? You tend to find a lot on APIs. Now, it's not just on APIs, but you find it a lot on APIs, and especially on data where you have things like foreign keys, where you have these really complex data structures, this really complex access control system. You kind of have this like recipe for disaster security-wise. It's really complicated. It's very easy for a developer to make a mistake. So you might have heard these called IDORs before. And that's because an IDOR is kind of a type of broken access control. I think a lot of people kind of think they're two different bugs. They're not really, but they are slightly different. So in an IDOR, you have some endpoint, that means some piece of working code that you can access that gets documents. Now what you pass to that endpoint is a document ID. And hopefully the system will look up and see, is this your document, before it lets you do that. In broken access control and in IDORs, it doesn't do that check. It doesn't have that little if statement that says if owner of this resource is not the same as the person requesting it. And here we can see an example. So we have blue background man saying, hey, I would like the document which has the number or the ID of 1,000. And we can see that 1,000 is actually owned by the same user. Great, we'll send that. However, if we go into the request and we change that number 1,000 to be, say, 1,002, if it's an IDOR, if it's got broken access control, you can see even though this document is owned by green background man, it will still send it back to blue background man, even if he doesn't have permission. Now, the complexity with this comes when we start to think about all the different ways we can grant permissions, and particularly in enterprise software, this can get muddy very, very quickly. So why do we have IDs? Well, most websites are powered by some kind of what's called a relational database. So that is to say that we have a table called customers, which has something called a customer ID, which uniquely identifies each customer. And you can see here, customer ID 1 is Homer Simpson, for example. And we also have other tables. So we might have users, we might have orders, we might have books. And you can see in orders, we have a link between the user ID and the book ID. So this is what's called a foreign key, aka it's the foreign version of this. So this is saying order number 93 is for the user ID 11 and it has the product of 123, which is Aurora, and the user is Sadio. IDORs will always use the primary ID, so order number, but when testing an API endpoint, you should always be aware whenever you see underscore something ID, that is probably an endpoint that exists that you just haven't found yet. So broken object level authorization / BOLA, accessing an object owned by another user that has no protection on whatsoever. So it's not got any permissions, it's not got discretionary access control. It's almost like the access control is switched off, kind of. Broken function level authorization is when a regular admin function can be done without as like a regular user. So that is when we start to think about our access control, role-based access control, being able to do something our role shouldn't allow us to do. Then we have missing access control. So missing access control means that nothing was ever implemented. It's not that it's broken. It's not that it's half implemented. It is completely missing. So often we see this as being able to be logged out and then being able to access an object owned by a user, regardless of if we're logged in. And the final thing we have is cross tenants. So in a lot of enterprise software, what they'll have is lots of companies using their stuff, think something like Google, and being able to access another organization's resources. Say you're an admin in organization A and you can access, the products in organization B, that is also broken access control. So in terms of how you should be testing, step 1, log out. Can you still access a resource while logged out? So often I call this removing the cookies. Can you log into one account and access an object owned by another account? That's our bowler. If we're able to kind of look at some admin functionality and do that while logged in as a regular user, that's our broken function level authorization. And cross-tenancy means we're accessing an organization beyond our own. So in a single tenant, what you might find is you'll have 3 separate applications that have 3 separate databases for 3 customers. In multi-tenant, you're going to have all the customers accessing the same app, and it might even be on the same database, but certainly they might be able to at least programmatically see the data from other tenants, but shouldn't be able to do anything about it. Like, shouldn't be able to see it, shouldn't be able to edit it, shouldn't be able to delete it, shouldn't be able to create new things on behalf of another organization. Now, where it gets complicated here is that if you're an admin in one organization editing a second organization, this is where we kind of see multi-tenancy type access control broken. And this is why I say that these bugs are really great for beginners, because the way these work often requires you to use your brain, and it takes a lot of perseverance to essentially test every single API endpoint. It takes a lot of just sitting there and being bored trying to do this. So multi-tenancy can be a great place of finding bugs because it just, again, it's that complexity level up. When we think about pros and the way they hack, they are very caught up in the way that, like, their usual methodology. They don't want to change the methodology. So that gives us as beginners a kind of route in, because we can focus on things like this, where they're not necessarily looking because it's annoying. So where do we find IDs? There's a lot of different places you can find IDs. So here's an example of YouTube. You might find it at the end of a URL. It might be kind of this kind of structure, or it might be a single number like 12. Now, we can also find it as a parameter here. So here's the ID on a specific web page with a parameter. We can find it in the hidden fields in post data. So when you're hacking something, you might see, oh, hang on, it's sending my cart ID, even though it shouldn't. And we also find them a lot in APIs. So here we might have show the resource name, so Pokemon, and then the ID, so 1 would show you information about Bulbasaur. And that, you can kind of find them everywhere. Once you start to look at them and start to actually see these in practice, you will see IDs everywhere. The difficult thing can come with predicting IDs. So you can see here, actually, I took this from a website, but they've got safer. And a lot of the ways people will prevent IDORs is actually by using a UUID. And a UUID is basically this randomly, not everything can be random, generated identification number. Now, this doesn't actually mean that we don't have an IDOR. What it means is that we don't have predictable IDs. Now, if we think about something like an API, our show here, Pokemon ID, or our show and then just /Pokemons to see everything here, for example. Now, this can easily expose a Pokemon's ID even if we can't necessarily predict it. So even if it's not going up in numbers, ID 1, 2, 3, 4, and instead it's got these random IDs, as long as we can find the IDs, the access control is still fundamentally missing. And if you have had a bug where someone has said, this is a UUID, so it's safe, I actually really recommend talking to the client about that, because that is still a vulnerability. It's slightly mitigated by the fact you can't predict them. As long as you can find the ID, it is a vulnerability. So to kind of summarize, we know we have a valid issue when we can access something without being logged in at all. We're logged out, fully logged out, and we can edit some data or something like that. We can access our account when logged into another account. So we've made account 1 and account 2. We can access account 1's data while logged in as account 2. Or we can access some admin functionality even if we don't have the permission level of admin or another role. So maybe we don't have editor privileges, but we can still upload subtitles, or we can still delete comments. Or finally, we can access data from another tenant. So we're in our organization and we're able to access data from another organization. So let's take BugCrowd, for example. Let's say you're a BugCrowd customer and you're running a bug bounty program through BugCrowd. You shouldn't be able to see bugs owned and managed by another BugCrowd customer unless you're maybe a triager and you triage for both programs. And this is why these issues are very simple, like technically very simple. You change IDs, you log out, you see if things still work. But they have a lot of complexity overall because they require a human brain in there to say, hang on a second, this isn't right. So to find access control issues, my number one recommendation is messing with the cookies. So cookies maintain your identity on a website. When you log in, the server will record your session and link you that session to a cookie. So you send its cookie and it goes, aha, this person is logged in. Now, these cookies will not usually be predictable. However, they may be JWTs. And don't worry, we're going to talk a lot about JWTs in the future. But all you need to really know is this identifies you to the server. So when you remove a cookie from a request, you're essentially logging out. But because you haven't accessed that logout endpoint, again, endpoint means it's something that has a function, it's code that does something, it's not erroring, it's not giving us a 404. You keep that session open so anyone can use that cookie, like yourself. However, you aren't removing that session so you don't have to log in multiple accounts. Now, when I talked about Burp last week, we looked at account containers. This is, I think, the really easy way of doing things. And actually, somebody pointed out, I'm going to leave this in the description, you can actually access this Burp add-on that will match your Firefox multi-account containers to your Burp, so you can see the different colors to show when you've logged into each account, which is really helpful. So the idea of these is that it lets you log into multiple accounts at once and all your traffic goes through Burp anyway. On one tab, you're logged into your account 1. On your second tab, you're logged into account 2. And what you're going to do is you're going to check whether or not you can access account 1's resources while on account 2's tab. And we'll be doing a demonstration, so I'll show you what this looks like in practice. So how do we actually do this? How do we access something without being logged on? Step 1, create an account, log in. Step 2 is you want to perform a bunch of requests. You're going to click on every button. You're going to go into Repeater and just remove the cookie. You're just going to delete that entire line. And essentially what this does is it treats the requests as if they came from no one in particular, someone who's logged out. And then we want to check to see if they've caused something to happen to our account. So has it caused, if we've, say, edited a post, has it actually edited the post or has it just returned an error? And we want to double check because an error doesn't necessarily mean it hasn't worked. It just means that it's errored. How do we access another user's resource? So this is where we start to get complicated. So we're going to create 2 accounts, account A and B. We're going to do a bunch of requests on account A. Then we're going to log into account B, go into Repeater, repeat all of those requests, and then change the cookie from A's to B's. And see if they've caused something to happen to account A rather than B. Now, it's really important that if the action happens to account B, let's say we make a post and we replace A's cookie with B's cookie and it makes a post on B's account, that's not a vulnerability. That is non-idle, that's not an access control issue. Instead, when you change the cookie, you're effectively logging on as another user. We just don't bother filling out the form. An action happening to account B while logged on to account B is the correct behavior. Making a post on B is correct. And anytime you play with cookies, you are impacting this session. So sometimes it's obvious, it will literally say like PHP session ID. Other times it will just be a JWT with your logged in details. Fundamentally, it is just not a bug if it happens to be. Finally, admin functions as a regular user. So we're going to create an admin account, log in, do a bunch of admin actions, log into a normal account, change A's cookies to B, and see if they've caused an admin action to happen and to occur. So let's actually go try this in practice. I'm going to do a little demonstration here and we can see what these actually look like. So I'll be back with you in a few minutes. Okay, so I am looking at Indeed. So Indeed is a Bug Crowd customer. Now, I'm not going to be showing any actual vulnerabilities here. I'm just going to show you how you can test for them. And actually, if we scroll down to Indeed, we can see they actually encourage us to look for things like cross-organizational lateral movement, tenancy issues, and it even mentions looking for things like access control issues. Down here, you see broken access control on account. So let's start there. So here is my little setup. You can see I've got, if I just make my window smaller here. It's always great to have the program up, by the way, while you're hacking, because it can be really helpful for just like double checking things. Sometimes they do talk about like how you can find stuff. So I've go into my scope settings and I've just put a little scope control on anything that starts indeed.com. I really recommend doing this. This helps a ton stop like really garbage appearing in your burp. And you can see here we've got like APIs, messages, profile, UK. Now, I actually don't really like hacking from the sitemap, so I'm going to go into proxy, HTTP history, show any in-scope items, just to clean it up. And I prefer to work from this because I like clicking a button and then it working. So in this tab, I'm logged out completely. On this tab, I'm logged into my BugCrowd Ninja account. So the first thing we're going to do is we're just going to try a bunch of things. We're going to add in, I don't know, some job titles. What were we? We were a hacker. Apparently a packer. I'm going to press save and I'm going to go into skill and I'm going to say I have skill in web security. Initially, all I'm trying to do here is just fill it up with stuff, like fill up burp with requests. Now, if we scroll down here, you can see this is what's happening. It looks like the way this works, it's pretty much all coming from to a GraphQL API. And you can see here, right, so we've got add skill, we've got web security, and we've got months of experience. Now, what we don't have here is any kind of secondary ID that says like account ID. So this can usually mean that it's not saying like this is the account we're applying this to, right? It just says nothing. But it doesn't matter. We're still going to fill it up. We're going to add maybe not a ready to work. Maybe we add some kind of headline, a street address. I'm willing to relocate. And essentially, all we want to do is just fill up burp with stuff. And what you'll see very quickly is this is actually very overwhelming. Like, it is overwhelming to be able to read all of this. And that's why I really recommend not getting stuck at a CTF for too long, because CTFs are really clean. They've usually only got a single vulnerability. They do not have the mess that is a bunch of logging scripts, for example. So again, we can see this is, here we go, this is good. So you see how this has an ID here? That could be our account ID. So this is a good sign that we should probably test this for access control issues. So we're going to right click on it, send to repeater, and you can see you got this whole thing again. We can send it again, see if it still works. And we're going to change that true to be a false because we want to see it change. I'm going to send it and double check that this has actually changed something on my account. So it's unticked that box. So all we're going to do is we're going to remove line 3. So this is the equivalent of logging out. All this does is removes the identification that says this is linked to my account. And I'm going to press send. And you can see it's missing Indeed Fed account ID header. So something is missing here. If we go back, we might be able to see something in here and see whether or not it's something that we say, for example, can change or view. And the answer is not really. But that's fine. So because it says the lack of header, what we might want to try is making a second account. Now, if we make a second account, we can see whether or not that using another person's account that has an account ID, it just doesn't match the one in the request, is still going to work. Okay, so now I have a second account, and we can see in here, we're inside a PhD 2, and we're going to find a request on the same URL, so APIs-indeed.com. This isn't because we have to, more because it makes it like if we know we've got the cookie in the correct format then. So all I'm going to do is take a look at one of these post requests, and I can see here that this is definitely logged into this account, right? So all I'm going to do is copy line 3 all the way down here, copy it. I'm going to go back into repeater, select line 3 here, and then paste it. And I'm going to press send. Now, does this still work? Well, if we have a look at my Indeed profile here, we can see, no, while it has said able to relocate to, it hasn't actually updated anything on here. Like, nothing has changed on this account. We can just refresh the page, double check, but nothing has changed. So we know this is not vulnerable. It looks like it could be, right? Like, it looks like this has worked. If we actually take a look, we can see, while it says able to relocate to, refresh the page, no, it's not changed. And that's essentially all we need to do. And this is time consuming. This does, and I genuinely, this does take a lot of time to do one request at a time. Actually, because this is a GraphQL API, it's even more complicated because we'd have to check every single query here and see whether or not it works. Now, if you want to get started on doing something like this, a GraphQL API can actually be really helpful because it's very precise in the data that you can send and what format it needs to be in. And that's essentially all you do. You would do the same even if you were doing like cross organizations. You make 2 accounts, you do something to account 1 and then apply it to account 2. And even if it's a different organization, does it still work, etc. So that's all you need to do. You're literally just going to, step 1, remove the cookie entirely. So all you're going to do is delete it. That makes it like you're logged out. And then we can see we've got missing Indeed account ID header. Which one has the accounts? Yeah, here we go. So double check them on the right account. Copy this. Go into repeater. Paste it in. So this is the request from my first account, but using the cookie from my second account. So it's got an identification number here. So that could be something like my account ID. Then I'm going to press send and see whether or not it still works. Make sure we're refreshing the right account. So this is inside a PhD at Bug Crowd Ninja, not inside a PhD 2. Scroll down, it hasn't changed that value. And you can sanity check, like we can go back to the working request that we sent first, send it, make sure that that is actually still working. You can see, okay, yeah, that has been willing, that has changed the willing to locate. And that's essentially how you test access control issues. So let's go back to the slides. I'm going to tell you a fun story and then we're going to wrap up. Okay, welcome back everyone. I'm going to tell you a fun story about a access control issue that I found on like a real website. I got a bounty for this and everything. So I was testing a social media website. I'm going to call it NotTube. It wasn't on YouTube. It wasn't anything to do with YouTube. YouTube is just a great example. So as I was testing for access control issues here, I was getting my standard no permission to edit. You can't edit this. You can't change this video because it's not your video. And that's fine. That's standard fare when you do access control issues. You will find a lot more failures than you will successes. But actually when you looked at it, you could see the title, the description, the thumbnail, and a bunch of other information about the video. Even though you couldn't edit it, you could still view it. And this is where I think access control issues get really interesting. Now this video was set to be private, basically. Nobody else could edit that video, like, nobody else could see that video. It was supposed to be private to me. But the access control, the lack of access control still showed me the title, the thumbnail, the description, the tags on the video. It still shows me all that information, even though it shouldn't. And this is why I think access control issues are some of the best things to look for. That did not require a lot of technical skills. That didn't even require any skills at all. That was a very straightforward bug. But by just thinking about, what should I be able to do and what can't I do, I actually got like a $500 bounty for it. So I really think these are some great bugs to get started with. So that is it for today's video. If you are keeping track of what I've been setting as like homework, have a go at this yourself. Try Indeed. Indeed is great. It's got a large API. Create 2 accounts with your Bugcrowd Ninja address. So that's your username and then a plus sign will make you more than one account. Create 2 accounts, see whether or not you can access account A from account B. Have a go at this yourself. Get a feel for it. I know it looks messy. I know it's hard. I know that if you've been doing CTFs, this is super overwhelming. And yeah, this is why most people don't kind of like struggle to get into bug bounties, because they kind of give up when they look at a real website and see, hang on, this is a complete and utter mess. So have a go yourself. You do not need anything special to start with. Just try and go through it manually. Get a feel for the process. I promise you do it on enough clients, on enough API endpoints, you test everything, you will find an access control issue eventually. They are really easy for developers just to leave in. But otherwise, I will see you all in the next video. I'll see you all next week. Bye, everyone.